So good morning friends. So today we will be again seeing one more experiment in the using the virtual lab. The virtual labs are having all the information ranging from theory to procedure, self-evaluation, simulation, assignment, quiz, videos, reference, feedback, everything is there. So during the difficult days where we cannot go out and perform the experiments at the college, or even if some labs are not available at certain locations, then using these virtual labs we can easily conduct the experiments and take the readings. Now in today's experiment we will be seeing the uh, mechanics of machine lab. In this one we will be seeing the which are the different experiments available which are applicable to our syllabus. Now in this one we will be seeing eccentric cam mechanism. By the name eccentric, the eccentric name itself indicates that uh, it is not along the center. Concentric means along the center. The cam and follower are along the same center, then that will be the concentric. And in case of eccentric, the cam and follower will be offset by certain distance. That distance will be called as the offset distance. So the advantage of having eccentric cam is nothing but it is a circular disc, but only instead of having the rotation of center at the center of the disc, the rotation center is slightly shifted by offset distance depending upon the displacement required. So if I am going directly to the simulation, you can see how we will be achieving the eccentricity. See, in this one we can see the variables r. R is the radius of the cam, that is base circle radius. Now we are having one term called as A. A is the eccentricity. Eccentricity is if I am stopping this one and making this one to say 0 degrees. Now can you see, this is our center of rotation and this is the point where our cam is attached. The cam is attached at a eccentricity of A equal to 10. If I increase A, see what happens. When I am making A as 20, the eccentricity has further increased. The center of rotation will remain same, but the point where we are attaching the cam is changed, means the eccentricity is increased. Similarly, if I am increasing further, you can see that it is moving still ahead. So up to this point I can increase in this particular simulation. So now without going for extreme values, first I will take only eccentricity of 10 and it is in the initial position. Now let us see at 90 degrees what will happen. You can see that the point has come in the downward direction. Now similarly for 180 degrees you can see that the cam is on the other side. Like this, if I am giving say rotation and if I am asking to plot the graph, I can see that because of this eccentricity I will be getting the displacement on both sides. Now the eccentricity is 10, so on both sides I will be getting a displacement of 10 and 10 mm on positive as well as negative side. So the total displacement or lift of the follower will be 20 mm. Similarly, I will be getting a curve for the velocity and acceleration, similarly jerk. The importance of jerk is rate of change of acceleration. Suppose we are standing and somebody suddenly comes and pushes us. Then at that time what we say? I suddenly experience the jerk. So the jerk is like a impact force. So it will be occurring instantaneously. So that type of impact will be very harmful for the machine elements. So that should be kept under control always. Otherwise there will be a problem of associated with the life of the machine elements. Now we will see one more thing. I will be making this as 0, eccentricity 0. Now what is happening? We are getting a straight line. If I am stopping once again, and if I make this as also 0, and if I simulate, now it is A, we will stop again, refresh, then I will make this as 0, now if I am simulating, now you can see that there is no displacement, no velocity, no acceleration and no jerk, because it is as good as we are rotating the circular disc about its center. So there won't be displacement for the follower. So the benefit of this eccentric cam is, by only changing the eccentricity values, I can get different displacement for the follower. Instead of going for a complicated shape of the cam, we have to just make a circular disc and change the position of center of rotation to get the required displacement. And in any cams, we have to keep one thing in mind: the pressure angle should be as low as possible. The pressure angle is an indication how quickly the cam is changing its profile. Suppose we are having two cases. In one case the pressure angle is 5 degrees, in other case it is 10 degrees. In the second case, I can say that the cam is changing its profile more rapidly, so that more jerk will be occurring. Like this, using the virtual labs, we can perform a number of experiments. Thank you.